Born in the industrial age, a child of science and manufacturing, the automobile could never claim to be a simple machine. Over the century, the demands we have placed upon it have only served to increase its complexity. Today, we place even greater demands on the automobile, demands that its inventors could never have envisioned. In addition to more performance, we ask for greater economy, less pollution, more comfort, and smaller size. And in response, the automobile has become increasingly more complex. Words like dual overhead camshaft, anti-lock brakes, and independent suspension have become common automotive terminology. But how many of us can claim to have any understanding of what these terms really mean, or how we benefit from them? Hi. I'd like to take you on a tour of sorts, a tour of the technical side of Hondas. On it, we'll look at some of their major technical features, things like overhead camshafts and double wishbone suspension. We'll also explain their benefits, how they work, and even sometimes how they're made. The place to begin such a tour is, of course, Honda. That means with ideas. Is engineering philosophy. It's what sets Honda apart from every other automobile manufacturer. A unique vision of what an automobile should be. You see, although Honda is one of the world's youngest automobile manufacturers, they have established a worldwide reputation for technical innovation. But unlike others, Honda innovation has never been merely for the sake of change. You won't find Honda engineers adding a feature to a car just because it's the latest gadget. Instead, Honda has always been guided by a belief that each change should make a contribution to the total vehicle. Take a look at how Honda designs and builds engines will help illustrate my point. Honda engines have been admired for their compactness, their power and efficiency. To be sure, there are others who build engines with these traits, but few have done it as consistently as Honda. This history of successful engine design is no accident, but a result of a careful process that begins when the engine designer sits down with a blank sheet of paper, or more likely these days, a screen, and asks, just what does a Honda automobile engine do? What do we require of it? At first, the answer may seem obvious. The engine supplies the power to propel the automobile. But as you'll see, when designing a Honda engine, there are many other factors that must be taken into consideration as well. For example, the engine must also supply power to various accessory systems, including the power steering and brakes, and a variety of seemingly doing so. For example, we expect an engine to be compact and powerful, yet still be smooth and unobtrusive. Consider compactness versus power for a moment. It's easy for an engineer to build a large, powerful engine, but Honda builds compact, powerful engines, and that's entirely another matter. Here's how it's done. Honda's used with the engine-mounted side. The benefit of this design is that it eliminates the bulky, space-robbing engine and drive shaft layout found in front-end vehicles. As a result, there's more room for passengers and cargo. But it also requires that the engine be designed and built as one unit. Now, the engine comes, to put it another way, small. But that usually means not very powerful, right? How do we make a small engine size and increase efficiency? Or a given size of engine makes, the greater its efficiency. Here's how Honda does it. At the heart of a Honda engine is a 4-valve combustion chamber. Now generally, the more valves a combustion chamber has, the more power it produces. There are several reasons for this. More valves improve an engine's breathing by letting more air and fuel into the combustion chamber and expelling exhaust gases more completely. As a result, the engine makes better power and torque over a wider range of speeds. Also, each valve is smaller and lighter in a multi-valve engine, so higher engine speeds are achieved more easily than with the larger, heavier valves found in 2-valve designs. It also helps to increase the engine's useful operating range. The simplest and most reliable way to operate multiple valves is to use overhead camshafts. Overhead camshafts are located in the cylinder head where they act directly upon the valves. There are no push rods. Fewer moving parts means greater reliability and durability. Another reason Honda engines are so efficient is because of Honda Programmed Fuel Injection, or PGM-FI for short. Here's how it works. At the heart of PGM-FI is a computer called an Electronic Control Unit, or ECU. The ECU is connected to sensors that monitor throttle position, engine temperature, cylinder firing position, intake manifold pressure, atmospheric pressure, exhaust gas oxygen content, and intake air temperature. The ECU uses this information to determine the fuel requirements of the engine. It then activates each fuel injector at precisely the right moment. The result is outstanding drivability and power, reduced emissions, and better fuel economy. An additional advantage of PGM-FI is easier maintenance and repair. The electronic control unit can sense when something is wrong with various parts of the system and flash a trouble code which will tell a technician where the problem is located. PGM-FI uses electronics to help make Honda engines more efficient. Another place where Honda uses electronics is to control unwanted engine vibration. The Honda electronic engine mount, used on Accords equipped with automatic transmissions, controls low-frequency vibration, the kind that occurs when the engine is idling with the air conditioning on. The mount contains two fluid chambers separated by a computer-controlled valve. At low engine speed, fluid is routed through the valve, damping out low-frequency vibration. As engine speeds increase, fluid is routed around the valve, making the mount firmer. The engine mounts used on other Hondas are special too. They're called inertial axis mounts, and you'll notice they're placed differently than in other automobiles. So they effectively control engine vibration over a wide range of engine speeds. The result is a quieter, smoother operating automobile. To minimize vibration on the larger, more powerful 2.2-liter Accord engine, Honda utilizes a specially designed second-order balance system. Here's how it works. A pair of rotating eccentric balance shafts mounted in the engine block cancel the vibration created by pistons and connecting rods. As a result, the Accord engine is incredibly smooth at all engine speeds. Power, compactness, and smooth operation. It's possible to get all three qualities in one engine. All it takes is a commitment to engineering excellence. Of course, if all an automobile had to do was go, it would only need an engine. However, it has to carry passengers and cargo as well. That's where the suspension system makes its contribution. Let's begin our discussion of suspension the same way we began our discussion of engines, by asking, what does the suspension system of an automobile do? The suspension system helps to effectively transmit acceleration, cornering, and braking forces to the road, and at the same time, let the driver control the automobile and isolate passengers from the various jolts and bumps the road dishes out. There are quite a list of demands. That's why Honda engineers selected four-wheel double wishbone suspension. Incidentally, Honda was the first manufacturer to utilize this system on all four wheels of a front-wheel drive car. It gets its name from the wishbone-shaped racing car suspension it evolved from, for its ability to precisely control the car's wheels while accelerating, cornering, and braking makes it superior to other types of suspension systems. Of course, Hondas benefit from this precise control as well. That's why they have such an outstanding reputation for road holding and cornering. But that still leaves ride to deal with. Now, generally, cars that handle well, like sports cars, ride too rough for most people to put up with. That's where double wishbone suspension offers another advantage. Superior ride over a variety of road surfaces. Here's how it works. The system's upper and lower links transmit handling forces to the road, leaving the springs and the shock absorbers free to absorb road disturbances and control ride motion, like this. Now, other manufacturers usually rely on struts like this for their independent suspension. They work pretty well, except that both handling and ride forces all must go through this one strut. As a result, some unwanted road noise and vibration are also transmitted to the passengers. Ride versus handling. Instead of compromising their design or picking one characteristic at the expense of the other, Honda engineers found a third solution in double wishbone suspension. The same kind of innovative thinking applies to Honda's anti-lock brake system. Anti-lock brakes provide an additional measure of security by allowing the driver to retain steering control during hard braking. This can be especially useful when braking on slippery or wet surfaces. When actuated, each wheel is held at the point of maximum braking and traction, the point just before wheel lockup and skidding occurs. It works by using electronic sensors at each wheel and an electronic control unit. When a wheel begins to skid, the electronic control unit senses this condition and sends a signal to the brakes, momentarily releasing, then reapplying them. If the wheel continues to lock, the system repeats the cycle, up to 10 times a second, faster than it's humanly possible to pump the brakes. Anti-lock brakes, multi-valve engines, and double wishbone suspension. In each case, Honda engineers found a solution which satisfied their goal of balanced engineering. But the area where this concept is best illustrated is the design and construction of a Honda body. Perhaps more than in any other area of automotive design, the body is called upon to perform the most tasks. In some way or another, it interacts with just about every part of the automobile. Of course, it houses the engine, suspension, transmission, and other major components, but that's just the beginning. The body must also provide a safe, comfortable environment for the driver, passengers, and cargo, contribute to the performance of the automobile, helping to improve its handling, acceleration, braking, and fuel efficiency. And, of course, it must look good and last a long time. Not an easy set of demands, but again, I think you'll see that Honda engineers came up with some clever solutions. Honda uses a unitized body. With this type of construction, there's no separate body and frame. Instead, both functions are accomplished with sheet metal stampings welded together to form strong box sections that resist twisting and bending. The shape of these box sections is determined by the use of computer-aided design. The result is a body that has maximum structural rigidity and safety without excessive weight. To help it last a long time, rust-proofing is built into the vehicle rather than added on later. For example, all body sheet metal is zinc-coated, with special attention given to the wheel wells and the firewall. Body panels are also designed to minimize water traps, so rust won't have a place to start. Oil-based sealer is applied along seams to protect against moisture and dirt. And chip-resistant paint is applied along the lower body sides to fend off stone damage. Spot welds are used in key areas where conventional welds would be more likely to rust. They say that beauty is in the eye of the beholder, but the attractive looks of a Honda must satisfy more than just the eye. It must also satisfy the wind. Aerodynamics yields benefits in several areas. For example, the more easily an automobile slips through the air, the less fuel it uses, so the better its mileage. Also, aerodynamic automobiles are generally more stable at highway speeds. Good aerodynamic design requires attention to details as well, like near flush fitting glass, flush headlights, faired-in mirrors, and faired-in door handles. They all help reduce aerodynamic turbulence and wind noise at highway speeds, and also contribute to a Honda's sleek appearance. But the most important thing a body of a Honda does is provide a safe, comfortable environment for its passengers. You probably heard the word ergonomics before. It's a Greek word meaning to fit the human body. To Honda engineers, this means designing the interior to respond to the needs of the automobile's single most important part, the driver. So controls and instruments are designed to make the driver's job easier rather than harder. For example, the steering wheel and the pedals are positioned for optimum ease of use. Switches and levers, located so that the driver can actuate them with a minimum of distraction. Their movement and feel relay a sensation of precision and control. You'll also notice that Honda meters and gauges are large and easy to read. Honda interiors are also designed to convey a feeling of comfort, roominess, and security. Seats are designed to minimize fatigue and have a broad range of adjustment, with some models having additional controls for lumbar and bolster adjustment. The roominess inside a Honda comes from careful attention to numerous space-related details. For example, the compactness of Honda four-wheel double wishbone suspension provides more room for passengers and cargo. The tall roof on four-door models and long roof line on the hatchback help create more rear seat headroom. Ample glass area and low hood and cowl height give the driver excellent outward visibility in all directions. Folding rear seat backs and lockable trunk-through access give Hondas a large and versatile cargo capacity. And trunk lids open at bumper height to make loading easier. Strength, style, aerodynamics, ergonomics, roominess. As I said, the body of a Honda has a lot of jobs to do, and it does them pretty well. I know we've only briefly touched on some important technical areas of Hondas. There are also many other interesting innovations we haven't covered. But I think the most important thing to remember is the philosophy behind all of this technology and innovation. Balanced engineering. A unique point of view that believes that each innovation should not merely contribute to one aspect of a Honda, but should benefit as many areas as possible. The result is an automotive personality greater than the sum of its parts. An automotive personality that is uniquely Honda.